Hello everyone, my name is Mohit and I welcome you all to my YouTube channel. I hope you all are doing great. This is challenge number 3 of solving DSA challenges playlist, and in this video we will discuss an interview problem on removing duplicate node from a linked list. Okay, so in order to understand the problem statement, let me move to the next slide. So if you see the upper half of this slide, we have 5 node in this linked list in which node with value 1 is a duplicate node, correct? Because first node and fourth node are having same value. So according to this problem, we have to remove this fourth node since it is a duplicate node, correct? So to achieve this, we have to implement some logic. And after the implementation, the processed linked list should look something like this, what we are seeing in the lower half of this slide. So if you observe here, node with value 1 has been removed. And this third node, which was pointing to node with value 1, which was duplicate node, is now pointing to this node. Okay. So this is our requirement. So if you see this final linked list, all the nodes value are unique, right? So before implementing this logic, let me discuss the high level approach, how we are going to tackle this problem. Okay. So in the original linked list, we will try to traverse through each node and we will try to check if the value of that node is already present in any of the previous nodes or not. If it is not present, then well and good. And let's say if it is present, then we have to remove this node and this next pointer of previous node should point to next node. Okay. So this is what happening in this case. The next pointer of node with value 3 is now pointing to node with value 5, which was next node of this duplicate node. Okay. So this is the high level approach that we are going to follow while implementing the logic. Okay. So let me move to Visual Studio Code and let us quickly start implementing the solution. Now let me bring the basic code in order to create linked list, and this we have been discussing since our first video. Okay, so we have node class inside which we have constructor, and node class has two attribute, value and next. Similarly, we have singly linked list class inside which we have constructor with these three attributes, head, tail and length. And also we have method inside this class called print value, which will print the value of node present in the linked list. And we have another method called append, which we will use in order to append a node. Okay, so this is some basic requirement which we have been discussing since our first video. So if you have any confusion here, I've already discussed each and every class and methods in a very great detail in my first video. So I strongly recommend to please refer that video so that you can understand and link the things in a more better way. Okay. Now let me define a function called remove duplicate. And since this is inside singly linked list class, we will put self keyword. Now, first thing that we have to check is the length of linked list. So if let's say length of linked list is 0 or 1, then we don't have to check anything for duplicate. Because if there is no node or linked list with single node, there is no possibility of duplicacy, right? So what we will do, if self dot length equals 0 or self dot length equals 1, we'll just do nothing. Okay. So for length equals 0 and 1, we have handled the condition. Now, starting from length equals 2 onwards, there is a possibility of duplicates, right? So, according to our approach that we discussed, we have to traverse through each node and we have to check if that value is already present in our previous nodes or not. If present, then we have to remove this node. Okay. So for that, I will create some temporary pointers. So first would be previous node. And let us point this temporary pointer to first node, which is self.head. And we will create another pointer called current node, which will point to second node, which is self.head.next. So self.head is pointing to first node, dot next pointer will point it to second node. Okay. So we have created two temporary node. Now, while traversing, we also want to check if the value of current node was already present in our previous nodes or not, right? So for that, we have to store the value of previously visited node. So for that, we have to store that value, right? So what we will do, we will create set scene values, which will store the value of previously visited node. Okay. Since our current node is pointing to second node, so let me store the value of first node here itself. Now, we will traverse through each node till we reach at the end of this linked list, right? So for that, what I will do, while current node is not none. So if you see here, let's say we are traversing through this linked list, and if we are reaching at the end, then after that, this next pointer will point to none, right? So we will exit the while loop once we reaches this condition. So basically, we have to traverse through each node till we reaches at the end of this linked list. So currently our current node is pointing to second node, and till it reaches to the end of this linked list, what we will do. So for every iteration, we will check if this current node value is present in the scene value or not. Okay. Then we have to write logic according to it. And let's say if it is not present, then what we will do? Let's say during while loop, you are at third node and this is your current node. So this current node dot value, that means 3, is not present in any of the previous value. So what we have to do? So first we have to store this value, and then the current node which was pointing to 3 will point to its next node, and the previous node which was pointing to 2 will point to its next node. Okay. So in else case, that means if current node dot value is not present in this scene values set, then we have to first store this value. So we will store this value in scene values set. And in order to add a value in set, what we have to do? Dot add. And next what we have to do? We have to move these two pointers to its next node. Okay. So previous node equals previous node dot next, and current node we will move to its next node, right? So this is the logic we will process when current node value is not present in our previously visited node. Now let's say we encountered a situation where current node value is present in our scene value. That means it was already present in our previously visited node. So let's understand this situation using this linked list. So during start of this while loop, previous node is pointing to first node and current node pointing to second node. Now we will start while loop. So current node value is 2, is present in any of the previous node or not? So answer is no. So we'll go inside this else. It will add second node value in this set, and it will move the pointer to its next node. So 1 and 2 will be stored in the scene values set, and current node will point to this node number 3, and previous node now point to node number 2. Again, current node is not none. So we will see if this value 3 is present in any of the previously visited node value or not. So answer is no. Again, it will go inside this else part, and it will store this 3 value in the set, and then it will move this current node to node number 4 and previous node to node number 3. Now again, this current node is node number 4, which is not none. Now it will check if this value, which is 1, is present in any of the previously visited node value or not. So yes, this value which we have already visited, and this value is already present in scene values set. So this condition will become true, and now what we have to do? We have to remove this node. Okay. So removing this node means this previous node dot next pointer was pointing to this fourth node. So now it should point to this node. And what is this node? This node is current dot next. Okay, so previous dot next should point to current dot next. So this is the first thing that we have to do. Previous node dot next should point to current node dot next. Okay, so by writing this line, we have ensured that this next pointer is now pointing to node with value 5. Now next thing is this node, which is duplicate node, should point to nothing. Currently it is pointing to this node with value 5. Now we have to remove this, so it should point to nothing. So for that, what we will do, current node dot next equals none. So current node dot next equals none. Third thing is, now we have to move the pointers, previous node and current node. So if you observe carefully, after removing this node also, previous node should be this, and only current node should be moved to this next node. Okay, so earlier what we were doing, we were moving previous node and current node both to its next node. But this time what we will do, previous node should point to same node. We just only have to move this current node pointer to its next node. Okay, so that in its next iteration, current node will become 5, previous node will become same as earlier, which is 3. So we don't have to do anything with previous node. We will just move current node pointer to its next node. So what is the next node? Previous node dot next. So after pointing this next node to node number 5, previous node dot next will become this node number 5, which is nothing but current node. So now only thing is, after removing a node, we have to decrease the length of linked list by 1. Okay, so now it is done. So now let's test this function. So first, let me initialize this singly linked list class with value 1. Let me see if value is there or not. Yeah. So this has one node with value 1. And now let me append other values with 2, 3, 1 and 4. So it will create the same linked list what we are observing in the upper part of this slide. So here also 1 is duplicate. So now let me run it and print this value. I'll comment this line. So we have linked list with these values in which node number 1 and node number 4 have duplicate values, right? So now what I will do, I will comment this line and let me bring these line of code. So this first part will print the values of original linked list, and then we will call remove duplicate method. So this will remove the duplicate nodes from the linked list, and then again we will print what are the value present in this linked list. Okay, so let me save this file and let me run it. So if you see here, before removing duplicates, these were the value present in the linked list, and after removing duplicates, it has removed this fourth node, and now we have only four node present in this linked list. Okay, so let me add another node with value 2, and in the end also we will add another node with value 3. So in this case, node with value 1, 2 and 3 are duplicates. Okay, so let me again run this. See, this is the original linked list with 3 duplicate node, and after removing duplicates we have these values present. Okay, so this was the requirement as per the problem statement, and we have successfully achieved it.